Sorry for that interruption. Okay. If we're back, we're looking at angle or measure of arc DEF. So to find the measure of arc DEF, well, we've got the angle that intersects that arc. We've got angle D, so the measure of angle D is equal to the one half DF. DF, not DEF. Measure of arc DF. So if we can find the measure of arc DF, of course we would be able to find DEF. So 64 is equal to 1/2 measure of arc DF. So we multiply both sides by 2. So the 128 is equal to the measure of arc DF. Why is that useful? Well, that's useful because we know the entire circle is 360. So the measure of the major arc DEF is equal to 360 minus 128. So that would be 232 degrees. Okay. Let's continue. Theorem 10.14, intersections outside of a circle. So all of those intersections were either outside, or excuse me, inside or on the circle. Now we're going to take a look at our second objective, intersections outside of a circle. Okay. So the theorem in words: if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intersected arcs. So let's take a look at how this could shape up here. Okay. First example. Okay, two secants intersect outside, so these two secants intersect at point A. So the measure of angle A would be 1/2 the intercepted arcs. The intercepted arcs, BC, DE, the difference of the intercepted arcs, the difference fraction. If a secant and tangent intersect outside, so they would intersect again out at point A, again, it's still going to be 1/2 the difference in the intercepted arcs. So the intercepted arcs, BC, CD. Okay? And if two tangents intersect outside at point A, it'd be 1/2 the difference of the intercepted arcs. So the two arcs we see there. So example 3, use tangents and secants that intersect outside a circle. Find the measure of angle L. This is two tangents that intersect outside the circle, so the measure of angle L is equal to 1/2. What are the intercepted arcs here? Difference in KJH, measure of arc KJH, that's the major arc, minus the minor arc HK. Okay. So if we substitute values in here, we get 1/2 the measure of arc KJH would be 360 minus 102. 360 minus 102 would be 258. So KJH is 258 minus HK 102. So we plug that into our calculator as we see it there. 1/2 parentheses 258 minus 102. 78 degrees. So the measured angle L would be 78 degrees. The next example, we'll be looking for arc length CD. Okay, so we'll be substituting in. Here's a secant and tangent intersecting. So the measure of angle A would be 1/2 the measure of arc CD. What we're looking for. Minus, so it's the difference of the two arcs, so the intercepted arc, so BC. Okay. We substitute in here, measure of angle A is 56 degrees. 56 degrees equals 1/2 the measure of arc CD, what we're looking for, minus solve this. Multiply both sides by 2. 112 equals measure of arc CD minus 95. Add 95 to both sides. 112 plus 95 is 207. So the measure of arc CD is 7 degrees. All right, got more problems here. So the diagram shows the path of a light ray as it hits a drop of water. The ray is bent or refracted at points A, B, and C. If the measure of arc AC is 128, AC would be 128 degrees. Measure of arc XDY right here is 84 degrees. What is the measure of angle D? So what is the measure of angle D? Okay, so the measure of angle D is equal to 1/2 the difference in the intercepted arcs. Well, what are the intercepted arcs? XBY and AC. So 128 minus 84. So the measure of angle D is equal to, we just plug that into our calculator, 1/2 128 minus 84, close of parentheses, 22 degrees. Here at the bottom of the notes, you guys, we've got a summary here, formulas, and your homework assignment, 8 through 26 evens on page 746.